No, using a clamp-on meter on a 24 volts direct current circuit to measure peak current will not provide a reasonable approximation of the current. Clamp-on meters are generally designed to measure alternating current, not direct current. Alternating current flows in both directions, creating a waveform with a peak value and an average value. Direct current, however, flows only in one direction, which means there is no peak value. When peak current is measured in a direct current circuit with a clamp-on meter, the reading displays the induced voltage that is caused by the changing magnetic field surrounding the conductor. The induced voltage is proportional to the rate of change of current, not the actual current. This makes the peak current reading from a clamp-on meter on a direct current circuit significantly higher than the real direct current. To accurately measure direct current, a multimeter should be set to the appropriate direct current range. A multimeter is an essential tool for electricians and electronics technicians, and understanding how to use it correctly is crucial for accurate measurements. The multimeter measures voltage, current, and resistance, and with proper configuration, it can accurately measure direct current. When selecting a multimeter for direct current measurement, one should consider a few key factors. Firstly, ensure that the multimeter has a direct current measurement range that is appropriate for the circuit being tested. Multimeters typically have multiple ranges, such as milliamps, amps, and even higher ranges for industrial applications. Choosing the correct range is essential for accurate readings and preventing damage to the meter. Secondly, the multimeter should have a sufficient resolution for the application. Resolution refers to the smallest change in current that the meter can detect. For precise measurements, a multimeter with a higher resolution is preferable. Thirdly, consider the accuracy of the multimeter. Accuracy is a measure of how close the meter's reading is to the true value of the current. Multimeters with higher accuracy ratings provide more reliable measurements. Before using a multimeter to measure direct current, it is important to understand the circuit being tested and the expected current range. The circuit should be de-energized before making any connections to prevent electrical shock or damage to the multimeter. Once the circuit is de-energized, identify the point in the circuit where the current needs to be measured. This is typically done by breaking the circuit at that point and inserting the multimeter in series with the circuit. Next, connect the multimeter to the circuit using the appropriate test leads. The black lead should be connected to the common or ground terminal on the multimeter, and the red lead should be connected to the amps terminal. Make sure that the leads are securely connected to both the multimeter and the circuit to ensure accurate readings. With the multimeter connected in series with the circuit, energize the circuit and observe the reading on the multimeter's display. The display will show the direct current flowing through the circuit in amps or milliamps, depending on the selected range. Take note of the reading and compare it to the expected value to verify the accuracy of the measurement. It is important to note that the multimeter introduces a small amount of resistance into the circuit when it is connected in series. This resistance can affect the current flowing through the circuit, so it is important to minimize the impact of this resistance by using a multimeter with a low internal resistance. Additionally, avoid using long test leads, as they can also add resistance to the circuit and affect the accuracy of the measurement. In addition to using a multimeter, there are other methods for measuring direct current, such as using a shunt resistor. A shunt resistor is a low-value resistor that is placed in series with the circuit. The voltage drop across the shunt resistor is proportional to the current flowing through the circuit, so by measuring the voltage drop, the current can be calculated. Shunt resistors are often used in high-current applications where it is not practical to connect a multimeter directly in series with the circuit. When measuring direct current in fire alarm circuits for signal horns, accuracy is particularly important. Fire alarm systems are designed to protect lives and property, so it is crucial to ensure that all components are functioning correctly. Signal horns are an integral part of the fire alarm system, and they must be able to produce a loud and clear alarm signal in the event of a fire. Measuring the direct current flowing through the signal horns can help to identify any problems with the horns or the fire alarm circuit. For example, if the current is too low, it could indicate that the horn is damaged or that there is a problem with the wiring. Conversely, if the current is too high, it could indicate that the horn is drawing too much power, which could overload the fire alarm circuit. By accurately measuring the direct current flowing through the signal horns, technicians can quickly diagnose and repair any problems with the fire alarm system. This ensures that the system is functioning correctly and can provide reliable protection in the event of a fire. In summary, measuring direct current accurately requires the use of a multimeter set to the appropriate direct current range. Clamp-on meters are not suitable for measuring direct current, as they measure induced voltage rather than actual current. When using a multimeter, it is important to choose the correct range, resolution, and accuracy for the application. The circuit should be de-energized before making any connections, and the multimeter should be connected in series with the circuit. By following these guidelines, technicians can accurately measure direct current and troubleshoot electrical circuits effectively. Understanding the difference between alternating current and direct current is paramount when using electrical measuring tools. Alternating current, commonly found in household outlets, periodically reverses direction. This change in direction creates a waveform characterized by a peak value, which represents the maximum current reached during each cycle, and an average value, which is the effective current delivered over time. Direct current, on the other hand, flows in only one direction as supplied by batteries or direct current power supplies. Because it does not change direction, it lacks a peak value in the same way as alternating current. Clamp-on meters are designed primarily to measure alternating current by detecting the magnetic field generated by the current flow. The meter then calculates the current based on the strength of the magnetic field. When used with alternating current, this method provides an accurate reading because the alternating magnetic field is consistently changing. However, when a clamp-on meter is applied to a direct current circuit, the magnetic field is constant and the meter's internal circuitry is not designed to interpret this type of field accurately. The meter may detect a transient magnetic field when the circuit is initially energized or de-energized, but this is not a reliable indication of the actual direct current. The induced voltage that a clamp-on meter detects in a direct current circuit is related to the rate of change of the magnetic field. Since the magnetic field is relatively stable in a direct current circuit, the induced voltage is minimal and does not correlate with the actual current value. This is why the peak current reading obtained from a clamp-on meter in a direct current circuit is significantly higher and misleading. To measure direct current accurately, a multimeter must be used in direct current mode. A multimeter measures current by directly sampling the current flow through the meter's internal circuitry. This is achieved by connecting the multimeter in series with the circuit. This means that the circuit must be broken at the point where the current needs to be measured, and the multimeter is then inserted into the gap to complete the circuit. When selecting a multimeter for direct current measurement, it is crucial to choose a meter with an appropriate current range. Multimeters typically offer several ranges, such as microamps, milliamps, and amps. Selecting the correct range ensures that the meter can accurately display the current value without being overloaded. If the current is higher than the selected range, the meter may display an overload indication or, in some cases, be damaged. The resolution of the multimeter is another important factor to consider. Resolution refers to the smallest increment of current that the meter can detect. A higher resolution allows for more precise measurements, particularly when dealing with low current circuits. For example, a multimeter with a resolution of 0.1 mA can detect changes in current as small as 0.1 mA. Accuracy is a measure of how closely the multimeter's reading matches the actual current value. Multimeters have a specified accuracy rating, typically expressed as a percentage of the reading plus a number of digits. For example, an accuracy rating of plus or minus 0.5% plus 2 digits means that the reading may be off by up to 0.5% of the displayed value plus an additional 2 counts on the least significant digit. When making direct current measurements, it is essential to ensure that the circuit is energized before making any connections. This prevents electrical shock and protects the multimeter from damage. Once the circuit is energized, identify the point where the current needs to be measured. Break the circuit at this point and connect the multimeter in series, ensuring that the positive and negative terminals of the multimeter are connected to the corresponding points in the circuit. After connecting the multimeter, energize the circuit and observe the reading on the display. The reading will indicate the direct current flowing through the circuit. Compare this reading to the expected value to verify the accuracy of the measurement. If the reading is significantly different from the expected value, double-check the connections and the multimeter settings to ensure that everything is configured correctly. Fire alarm circuits for signal horns require precise current measurements to ensure proper operation. Signal horns are critical components of a fire alarm system, providing audible alerts to building occupants in the event of a fire. The current drawn by the signal horns is an important indicator of their functionality. If the current is too low, it may indicate a problem with the horn itself or with the wiring connecting the horn to the fire alarm control panel. Conversely, if the current is too high, it may indicate a short circuit or other fault in the horn or the wiring. Measuring the direct current flowing through the signal horns allows technicians to diagnose and troubleshoot any issues that may arise. This ensures that the signal horns are functioning correctly and can provide reliable alerts when needed. In addition to using a multimeter, other methods for measuring direct current include using a shunt resistor. A shunt resistor is a low-value resistor that is connected in parallel with the circuit. The voltage drop across the shunt resistor is proportional to the current flowing through the circuit. By measuring the voltage drop across the shunt resistor, the current can be calculated using Ohm's law. Shunt resistors are often used in high-current applications where it is not practical to connect a multimeter directly in series with the circuit. It is crucial to remember that clap-on meters are not designed for accurate direct current measurements. They are primarily intended for alternating current measurements and should not be used in direct current circuits. To accurately measure direct current, always use a multimeter in direct current mode, following the proper connection procedures and safety precautions. In conclusion, while clamp-on meters are useful tools for measuring alternating current, they are not suitable for measuring direct current. To accurately measure direct current, a multimeter must be used in direct current mode, following the proper connection procedures and safety precautions. Understanding the difference between alternating current and direct current and the limitations of different measuring tools is essential for ensuring accurate and reliable measurements.